Hello Year 8, here are the answers to your 5 a day. So we've got to expand the brackets first. So we do 4 times 3x over 7. Remember this is like 4 over 1. So that gives us 12x over 7. We also need to do 4 times 3. We don't need to bother about the over 1 part here. And then outside of the bracket, so we're not multiplying this by 4, we subtract x over 7. Now we can see we can simplify because we have 12x over 7 minus x over 7, so that gives me 11x over 7 plus 12. Expand the brackets here, I've got lots of negatives going on, so I need to be careful. Negative 12 times negative 7d, positive 84d. Negative 12 times negative 9f is positive 108f. The mean of three numbers is 5. Two of the numbers are 3 and 8. What is the third number? That tells us that 3 plus 8 plus the number that we're trying to find divided by 3, because when we find the mean, we add the numbers together and divide by how many numbers there are, equals 5. So now to solve this equation, I can multiply both sides by 3. 3 plus 8 is 11. And then subtract 11 from both sides. So x equals 4. Let's double check. 3 plus 8 plus 4 gives me 15. Divided by 3 gives me 5. That's what I wanted. The square root of 81 is 9. Now this is the positive square root. If you were thinking about it, you could say you know that that negative 9 times negative 9 is also 81. Remember, evaluate just means find the value of. So this means 3 times negative 7 squared. We use indices before we do multiplication. So this gives me 3 times negative 7 is 49. And then 3 times 49, well 49 is nearly 50. 3 times 50 is 150, but I need 3 fewer because I've only got 49 threes rather than 53s. So that's 147. Today's lesson, we're going to be looking at congruence tests, the different tests that we can use to show that triangles are congruent. If we were asked to draw a right-angled triangle, it says here there are millions you could draw, but in fact there are an infinite number of right-angled triangles that you could draw, each with different angles. Obviously one of the angles is always the same, but the other two can be all different kinds of sizes, and so can the lengths. The idea of congruent triangles is to find the minimum information needed to describe a triangle that's unique, that's the only triangle that can be its size and shape. Our triangles can be rotations and reflections of each other, but they must be the same shape and size. Okay then, so to prove two triangles are congruent, there are 4 different reasons that we can use. SSS, ASA, which is sometimes called AAS, SAS, and RHS. And we're not going to worry about this now, but in the future, next year, you'll have to give reasons why sides or angles are equal. So let's have a look at what these strange codes are. SSS stands for side, side, side. And that tells us that 3 sides are the same. So if we have 2 triangles where each of the sides correspond to each other, they're the same length, then these 2 triangles are congruent. ASA tells us that two angles and the included side, that means the side that joins the two angles, are the same. So if I know that, for example, this was 45, this was 2 centimetres, and this was 50, then, and this is 45, 2 centimetres, 50, then I would know that these two triangles are congruent. Then it's in a slightly different order. RHS stands for right angle, hypotenuse, side. So if you have two right angled triangles, and you know that their hypotenuse is equal, and one of their other sides is equal, then the two triangles are congruent. And finally, SAS is two sides and the included angle. So the angle in between the sides, if they're the same, then the two triangles are congruent. Pause the video now and can you write in your book everything on the screen, including the diagrams and the little dashes on the sides and angle indicators. Okay, so here's an activity that you're going to have a go at. We'll have a look at one or two together and then we'll go through the answer. So amongst all of these triangles here, there are pairs of congruent triangles. I want you to find them and state the reason for congruency. The reason, you can just use the 3-letter version. So in this example here, I've got A. Now for triangle A, I'm given 3 sides, so I want to find another triangle that has got 3 sides that are the same length. So I have a look across the whole screen and I can see here down at N, I've got 8, 10, 13 like A, 8, 10, 13. Now I've used those two, so to make it easier for me, I can cross those off. And the way I show that they are congruent is these 3 lines here. So I write triangle A, because it's got the A next to it, is congruent to, so it's like an equal symbol but with 3 lines, triangle N. And in brackets, my reason is SSS. I'll do one more with you. Let's have a look at triangle B together. So I'm going to write triangle B is congruent to. Now triangle B is a right angled triangle. Its hypotenuse is 5, and one of its other sides is 3. So we need to look across the whole thing. I need to find some other right angled triangles. This has a hypotenuse of 5 and it has an other side of 4. But if you recall Pythagoras' theorem, you'll remember that a squared plus b squared equals c squared. So let's have a quick look if that works for this one here. If I have 5 squared equals 3 squared plus, I'll call this x squared, then I have 25 equals 9 plus x squared. Subtract 9 from both sides. 16 equals x squared. So 4, which is the square root of 16, equals x. That's not x squared, sorry, that's just x. So that side's 4. So I know that these two go together. So I and B, it's a nice reminder of Pythagoras there, go together because we have a right angle, an equal hypotenuse, and a side. Pause the video now while you try to find the other pairs. Okay then, so you should have worked your way through all of the, what do I have, 22 triangles there, so we should have 11 pairs. I'm not going to talk too much, I'm just going to write down the answers and you can mark your work as I do it. This is a C. Okay then, and so here are the other answers. Pause the video while you mark your work. Some of them you have to work out another angle. For example, this one here, we needed to work out that these add up to 128, and so this one must be 52, and so on. Okay, to continue practicing on these, there are 3 online activities that I would like you to do. If I haven't done this already in the conference, please ask me to give you the hyperlinks for them so you can just click on them. Work your way up to the end of the lesson on those, and then we're done. Let me know if you have any questions. Thank you.